So basically, a hackathon is a 24-hour or 48-hour event, usually like a weekend or something, where people come together, they form a team, and they build software. They work as a team, and they try to come up with something like a web app or mobile app or whatever it is you want to work on over a 24-hour period, and it's a contest. So at the end, there's a winner, and there's usually prizes and things like that. And so basically, I'm trying to. It's a really fun event. So I'm basically trying to get Facebook to sponsor us. You guys know Facebook, right? Yeah, obviously.
What is that?
Anyways.
I think from the movies.
Yeah. Anyways, it'd be good exposure. It's a good resume piece if you attend something like this, and if you want to work there, if you win the contest, then there's a good chance, you might be recruited, or you'll get a tour of Facebook or something like that. I don't know what they do, but they'll probably provide us with prizes and things like that. But basically, I need as many people to sign up as possible to see how many people are actually interested, so that they can actually sponsor the event. What else? Well, if you have any questions, just ask me. But any questions so far about what this event's about? Yeah.
Any idea like when this would take place?
Oh, sorry. Yeah, it'll most likely happen this spring, because I haven't reserved everything yet, but probably mid to late spring. That's any other questions? Yeah.
So signing is not mean participating as well.
No. Just sign up if you're interested. I would do it anyways, because you don't have to go, but we'll probably be able to bring it back. Yeah, I hate it.
Is it going to conflict with the NISA competitions? The NISA programming competitions? You might want to just make sure that you're not overlapping with that, because it's like a 2-week thing where they give you a goal and then 2 weeks to complete it.
I see. Okay, yeah, I'll look into that. But I'll make sure it doesn't conflict. So I'll pass around this sheet. If you're interested, just put down your email and your name. Thanks.
Alright guys, so real quick, some announcements. And that's awesome. So this Friday is Install Fest. So free food, and basically come here at 6 in this room on Friday, and we will help you install Linux on your computer, either dual boot or virtual machines.
Does food include drinks for that?
Yes.
Cool.
If you want to dual boot, make sure you defrag your hard drive before you come. Also bring your own networking equipment. And we are doing Frag Night again this quarter. It will probably be 9th week. We don't have a hard date for that yet, but we will get that to you soon. So that's all the announcements. So we have, this week we have A.D. Hunter. He is the former president of Swift. He's also a minor god of networking. And he's also a bulldozer. If you want to know that story, you're going to have to ask him. So he's talking about live CDs this week. For those, well, I'm sure he'll go over what a live CD is in his presentation. So, switch back.
Hey guys.
Hi.
Glad to be back. So today I'm going to talk about creating custom live CDs. But first I'm going to start off with a little bit about live CDs in general, in case you guys don't know a lot about live CDs. So basically, what are live CDs? They're temporary environments that use a read-only media, and it breaks to RAM temporarily. And usually they're booted from CD or DB, but sometimes they can be hard drive, USB, network. And the important thing is that they're a fully functional environment where you can do lots of different things, but that they're non-persistent. That when you reboot the computer, all the changes that you made go away. And some people think of live CDs that normally they include like graphical desktop, like the Ubuntu live CD, but that's not always the case. That has nothing to do with whether or not it's a live CD. The uses for live CDs are so that you can try out something before you install it. So like Ubuntu, Fedora, they provide live CDs so that you can get in there and you can have a look at the tools that they come installed with by default, the different ways that they have configuring things. They allow you to install most operating systems. They package their installer CD as a live CD so that you get in and then you actually have a full Linux environment that has a predefined set of scripts that help you install that operating system onto your hard drive. Pretty much all the distros do that kind of thing. Then there's also live CDs that help you repair old operating systems. So if you if you need to recover Windows because the Windows just crapped out on you and you need to copy your files off, you can use a live CD to copy those files to something else. Or if you somehow mess up your grub configuration and you need to be able to fix your Linux system so that you can continue booting, then there's live CDs that'll help you with that. The reason why people use live CDs are simplicity because they come with pre-installed and pre-configured software. So like in the case of Backtrack, which is a penetration testing distro, it has tons and tons of tools related to security, penetration testing, hacking. All those are built in, pre-configured, ready for you to use so that you can get in there and do the things you need to do without having to worry about are these programs compatible with my system? Are they is there a lot of effort required to installing them or configuring them? Or also there's the use of security where now if you want to do something that you don't necessarily want someone to be able to find out that you did, being able to use a live CD helps you do that because it doesn't write anything to the disk. It doesn't take it doesn't cache your RAM to disk in the case of a swap file. You're not modifying anything on disk, so your Firefox profile isn't being written to disk at any time. So only do this, for good things, but basically it's a way of making it so that you don't actually ever touch your hard drive for that, if you don't want people to find out what you've been doing. Or consistency is the thing that comes with live CDs is that every time you reboot it, it's going to come back to exactly the same state as it was the last time you rebooted it. There is no staging of the state. So you can mess it up all you want, try out anything, and you're not going to harm your system, unless if you're actually modifying your disks in your computer, then you'll have a problem. But the actual environment that you get is going to be the same across reboots. So, which is also kind of a problem because if you actually do want to make changes, then you have to go and you have to make a brand new live CD.
So essentially, you can get a virus on the system and it won't do it.
Yeah, pretty much. Because if you suspect it's a virus, all you have to do is just reboot and it goes away. So I already talked about some of the popular live CDs. There's Ubuntu and Fedora, which are test environments for the installation process of those operating systems. There's also Backtrack, which can be installed, but it's not generally meant to be installed. It's meant to be impermanent, where you just you use the tools, get your job done, then you reboot back into your normal operating system where you have everything, your normal operating system. Then there's also Gparted, which is a very popular live CD that's used for repartitioning hard drives, recovering hard drives, or changing operating systems around. If you guys come to install Vestin, there's a good chance you'll use Gparted to actually repartition your drive if you want to dual boot. But then an alternative Gparted is actually called Parted Magic, which this is one of my favorites. It does basically the same thing as Gparted, but it's a little bit more robust as far as the tools that it includes with it. And personally, I like it way better than the Gparted CD. So the Ubuntu Live CD is a try it before you buy it kind of thing. But notice the Ubuntu is free as in beer software. Yeah.
So a question, say if you wanted to test how a program would affect your system, could you install these live CDs just to see how it would affect your OS?
Yeah. Usually, so like Ubuntu, you can use that, and you can go in, you can use apt-get, and you can install, a new version of the package, or you can install a new package or an updated version of the package, and you can test that out without having to actually install it on your regular system. So if you, just in the course of testing something, you can try that. So live CDs are also great for testing new things in virtual machines because you don't need to do the install process of testing something out. you can get a pretty good feel for how everything works. See if you're happy, happy or not with it. Like, probably like once a year, whenever the new Ubuntu thing comes out or the new Fedora thing, I load it up in a virtual machine and I just give it a whirl to see, what they've changed and if I'm happy with it. And I actually found that no, I'm not happy with it. But the Ubuntu ICD, it allows you to install Ubuntu, allows you to fix your system, or if you need to, you can get in there and you can do some quick web browsing or use OpenOffice to do some quick document editing. So it's more of a general use kind of live CD, where you can do whatever you might need to do. Backtrack, like I said, is more security focused, so it does penetration testing, security, forensics, good for analysis. It does include some general use things, so it does have Firefox. I don't know if it does OpenOffice, but it does have some text editors of some sort. But it's nowhere near as polished as like Ubuntu would be for just general use. But if you guys can see, you probably think that's all blurry. But these are all tools that Backtrack install for you that have that have some sort of use, either penetration testing, hacking, or forensics, reverse engineering. So there's lots and lots of tools on this Live CD. Just about anything that's in the industry that you might need. It's actually so big that it only comes on a DVD. It's like 2 gigs or something like that, because it's got so many tools installed in it. The other one that I mentioned was Part Magic. This one, it's actually really nice and small Live CD. It's much smaller than the Ubuntu Live CD, but that's because it doesn't include really large programs like OpenOffice. It doesn't include a full GNOME desktop or Unity or whatever it is. This one is based off of LXD, which is a very lightweight desktop environment. And it's basically just a system repair and restore tool. But it's very lightweight. And generally, I use that for if I need to make like a backup of a hard drive or something. It does include Clonezilla, which is a really good it's a tool for making backups of a hard drive, so you can copy that out onto another hard drive at a later time. So like you can clone it across, like if you had a lab with computers or something. Clonezilla is great for that. We use it for CCDC. So Part Magic is a pretty decent, just kind of generally used repair one. But it's possible that not all these live CDs really fit into something that you want to do. So there is the option of making your own live CD. And you might ask, well, why would I want to do that? And my reason for it is, my own personal mix of programs. I can personalize it however I want, change the theme or whatever, so that I don't have to go and tweak a live CD when I boot it up. It's already the way that I want it. And I've been working on a live CD for work now for about a year, and it has been a great learning experience as to how Linux works, the whole boot process. So it's one of the better things that I work on at work. And if you're interested in knowing how Linux boots, building a live CD from scratch is probably one of the best ways of doing it, because there's plenty of guides out there that show you how to install Linux and tell you what you need to do to get it working. But if you want to go and change that, it's a little bit more difficult. And a live CD can sometimes have a certain problem that you're trying to solve that you actually need to get in there and fix it. And since every time you reboot, it's going to go back to the way that it was. You can't just slap a Band-Aid on it once after you booted and have it be fixed forever. As you do with the regular installation. So you got to go and you got to look at the boot process and see what you might be able to change to actually get there and improve your CD in some way. So how can we make a live CD? And there's lots of live CDs out there. So why not just choose one that that you're happy with, maybe Ubuntu, and go and customize that. So when I was making my live CD at work, one of the things that I started with, I was like, okay, well, I'll look at Ubuntu. And I was like, okay, well, I'll choose Ubuntu because, a lot of people know it, so it's going to be really easy to get started with making a live CD. It's I can install lots of packages. There's pretty much anything that you can possibly want in the repos. If I needed any help with anything, there's probably someone else that's already done it, because a lot of people use Ubuntu, so it's going to be It's widely used. You know, the community support is pretty good. And the thing that I was hoping for is that the process of making a live CD was going to be really simple. That someone had already made you know, a tool or a set of scripts or something that'll go through, and I just have to, you know, make a little bit changes, tell what packages I want, and you know, I'll have a new CD. But it turned out that Ubuntu wasn't exactly the greatest because, first of all, it's Ubuntu. I'm not actually really happy with Ubuntu. I just assumed it would be easy, but every time I've actually used Ubuntu, I've ended up hating it. So. And if you actually go and check out these links right here, these documents as to how to actually this guide is how to build an Ubuntu Live CD from scratch, and it is not short. There are a lot of steps. So, you know, I gave it a whirl for about 2 weeks, maybe 3, and I hated it. It was just terrible to work with because everything that I wanted to do, because basically what the Live CD does, or what the process entails, is you take a normal Ubuntu CD, you rip it apart, and then you go and you go inside it as like a virtual environment almost, and you install inside there, and then you go out of it, and then you recreate the ISO, which to me just seems very clunky and, you know, not the most efficient way of doing things. So, you know, I tried scripting it, and script would always break because, you know, I didn't want to spend all the time trying to make a tool that, you know, did everything right and checked for all these error conditions, and things would just error out sometimes. So it's just not a very ideal environment to be building it in. So then after that, I moved on to Arch Linux, which I'm sure most of you guys here that, you know, I'm sure that the Swift crew has told you guys about Arch Linux, and you know, you should use several months. Who here is an Arch Linux fan?
Master race.
Okay.
Arguing with yourself.
So Arch Linux is my favorite distro, so I went and I looked at, you know, what process did they use for making their live CDs. And I found that it was easy to use, not very complex, and then it gave me a very good introspection of the process, so that I can see, you know, this is what it's doing, so I can understand why it needs to do that, and better understand how my CD is being created, which was great for, you know, just personally being fulfilled about how I'm building this live CD. So the package that Arch Linux comes with, or it doesn't come with it, you have to add it in, but there's a package called Arch ISO, which is, it's the same set of tools that the Arch people use to make their own installation CDs, and they provide a baseline config. Basically, all it is just a shell script, and you can almost just run that script, and from the get-go get a brand new working ISO. You know, there's no configuration changes in it. It's a very basic script. It's basically as if you had installed Arch Linux and skipped the entire configuration stage. It's basically what you get if you had just rebooted into that system without doing the configuration. And I said that it almost works because there's one minor change that you need to add to actually get it to boot. If you don't do this, then it just kind of hangs in the process and doesn't know where to find your, doesn't know how to find the CD-ROM device, which is kind of lame. Actually, the interesting about that is that a year ago, the configuration actually included the necessary bits of it, and then over the last year, they've slowly removed those parts to make it not work. I don't know why they did that, but it's really easy to add it back in. I'll show you in a second how to do it. But also, you can run the release engineering script, and that'll actually create you your own custom Arch installation CD. So if you know, Arch goes another year without making a new ISO, then you can go and you can build your own, so you can install the latest versions of all the packages from the get-go without, if you can't use a net install for some reason. So they give you the tools to build your own live CDs for almost any purpose. So actually getting started with ArchISO is, there's two places that you'll want to go. One is going to be the wiki page. It'll tell you, it gives you the long process. So basically that Ubuntu page that I showed you, there's,
Sure, whatever. Sounds scary.
Trust Microsoft?
okay. So this is another really long page, but this is the very manual process. The ArchISO tools, they actually build a script that does all of this for you, so you don't need to worry about it. But if you want to understand the process, it's a great place to go to know what's going on, or if you need to change something, you can go here to see what's up. The other tool, or the other page that you'll need to check out is the Arch user repository page for the ArchISO. So you just get this. It's get the hardwall, build it, and I'll actually do that in a second. So this actually tracks your Git branch, so this is always up to date. If you don't see an update here, that's just because there's been no changes to the actual build process for how to get the package. But you'll want to check the. I actually don't have a link here, but they have. You can check the Git browser and see if there's been any changes recently to it. So actually, you know what we're going to do is I'll demonstrate to you how to build this ISO. So what you're looking at right here, this is a VM running back at my house. So I actually haven't. Okay. So basic first steps is we're going to get the ArchISO package. We're going to extract it. We're going to go in the directory. We're going to create the package. Then we're going to install it. All these at once. A few of these. So paste those in. Downloading it. Now to build it, it's got to install some dependencies. We'll go ahead and get those. It's going to install them real quick. Okay, so it just built it, nice and quick. We'll install it. Install the package. And now we have ArchISO installed. So now in this folder contains some basic configs. The baseline, which is a very, very basic live CD, and the release engine, which is actually what they use to make the live CDs for installation. So what we'll do is we will copy these. And so what I'm going to do is I'm going to copy the baseline. And then I'm going to initialize a Git repository in there, and I'm just going to use that so that I can show you guys changes that I make so I don't have to go back and find all the files. It's just going to be a quick way of showing you the changes that I make to the files. So we'll copy these. So, and then I need to add that thing I was talking about where you can almost build it from scratch without having to add anything. You need to add these keywords in there to this file. You need to add those in there so that it can actually find the CD-ROM device. You probably only need PATA, maybe SATA, maybe USB, but you'll just want to include all these so that your live CD can boot on any sort of device that you're going to put it on. You can even put it on a USB drive, do whatever you want after you include these hooks in this file. So we'll put it in right there. So now, using Git, I can show you that the only file that I've changed is this making it ctio.conf file, and I just added those few keywords to it. So now, with this, we're ready to just do the build. So this, actually, so, okay. So these are the files that are in that baseline directory. This is the script that actually will do all the work for you. And in a second, I'm going to run that. Actually, I'll run it now, and I'll talk about it. Okay. So, in the other directory, it's going through and it's installing packages for us, and it's going to go and it's going to do the basic live CD. Back over in this window, we'll actually look at the build script. So it sets up some things to do, setting up versioning. Here is where it actually installs the base packages. So base is a group. It's, includes all the basic stuff that you need for Arch Linux. Syslinux is going to be our bootloader. Here it's building the pre-boot environment, so that you can actually find the CD-ROM drive and set up the environment. This one it copies in the kernel and the bootloader, sets up file systems, and makes the ISO. And basically, this is just a bash script. So if you need to change anything in this process, you can go and you can just edit this file, and it'll do whatever you need it to do. And then down here at the bottom is where it actually does each of the functions that it has in the code. It just goes to them in order. The more advanced release engineering script actually has it so that you can do certain parts of these in certain orders, or you can do one part and then go and edit something and then go back and start the next part, all using one script with different options. But this script is a lot more basic, so it's a one-shot kind of thing where it just goes through and it does whatever it needs to do. So it installs some packages, created the initRD for the pre-boot environment. It set up the file system, compressed the file system, and then it created this ISO right here. And you can see it only took about a little bit less than 2 minutes to do,
Real.
5 minutes, yeah, I'm sorry.
Real is one.
Real?
Yeah.
Okay.
User counts multiple cores.
Okay.
That's
Cool.
actually
I see. So then, now that we have a working ISO, I'm going to use Linux KVM to actually run that. So there. That's the bootloader. It's going to start booting.
Wait, I don't know if we're allowed to have demonstrations work.
It hasn't worked completely
Just want to
yet.
shut up.
What?
It hasn't worked completely yet.
No, it'll work completely. I tested the hell out of this here. And there, we have a login prompt. We don't have a host name.
Yes.
These are all things that I'm well aware of. We'll go through and we'll fix these. So, login with root, there's no password.
Awesome.
Super secure.
It's like my computer.
What?
It's like my computer.
I actually don't have an IP address yet. So you can start DHCP if you need to. You can get an address. And ping the internet. All of it. All of it. So there, we have a very, very, very basic live CD. Great.
So, I saw you started up in KVM. Is there a reason for that? Just because it's easier than spinning up an entire ISO and VMware or something?
The reason why I did that is actually because to get it to boot into VMware is I'd have to use remote desktop back to my desktop at home, which I wasn't entirely sure if that was going to work very well. And then also, I have to copy it out of my development VM and put that in, and then put that on my desktop, and then boot it up there. So this just seemed like a little bit easier because I can just issue some port forwards to actually get to the VNC ports. So it just seemed easier. So that's great, but it's kind of boring because there's no extra packages in there. There's no host name. It doesn't do DHCP by default. So what we'll do is, already told you about those, is we can make some customizations though. So we'll go back to, so we'll kill the ISO. What? You guys don't like chicken conveniency?
It wants your attention.
It does want my attention.
Should have left it
Come on.
Okay. So what we're going to do is we're going to go here, and these are the lines that install some packages. We can put groups here, we can put packages, we can put whatever we need to. So, first off, let's get an X environment going. And then we need a display driver. You can put all these on one line. I'm just doing it so that they groups a little bit. XFCE for Firefox.
Actually, XFCE. You with self.
So, and then what I'm going to do is down here is after the make base FS, I'm actually going to call bash in there. And what this is going to do is it's going to create a shell for me so that I can go and I can customize it before it goes and continues the rest of the steps. So, so it's going to go through that first step, the make base FS, and then it's going to seem like it's ended for no reason, and I'm going to have a prompt, and I'm going to be able to do whatever I want. But if I exit that prompt, it will continue on with the rest of the build process. It's going to go through the final steps of this. So, two new things showed up in here: the out directory and the work directory. Out contains the ISO, and work contains some folders. In particular, this root image folder is actually where the intermediary files have been installed to. So I'm going to delete these folders, and then I'm going to go back and this.
Can you chroot into that root image folder?
Oh yeah, you totally could. So what Meta is asking is you can use the chroot command to basically change what the root path of the process is. So so I could do that. I could say change directory into work root image execute bin bash. But it's probably unhappy because I don't have the dev mounted or anything. I don't have the proc mounted. Sys mounted.
That'll work well.
So it kind of does work. If you're going to install packages in this mode, you're going to want to mount these file systems, which is perfectly fine. You can do that, no problem. And then you can install some packages. To install packages, you need to have your resolve.conf set up. Yeah. So and then just get out of that. So far, I've made 5 changes. I made 4 changes. I made that one change to the mknist.io so that it actually moves. I've added in 2 lines to install more packages, and I've added the bash, the call to bash, so that I can get a shell in the middle of this process. So I'm going to delete the work and the out directories so that I can start fresh, and then I will go and I will build everything again.
So I totally like the fact that you're using Git to show that it's really smart.
Yeah, I don't think it's good. Because, so the live CD that I have at work, I actually use Git to keep track of the changes that I make over the last year or so. So at any given time, I can go back and I can see my old way of doing things, which I'm not entirely sure if that's useful because since Arch moves so fast, there's actually been a major change in how they do things with their live CDs that a lot of the stuff that I had before is just completely incompatible. So there's almost no point to keeping track of changes that far back, but I have to. So.
Davey.
Yeah?
During this, I'd also like to mention that Gentoo has tools to do this too, and they have a really good handbook to do it.
But it's Gentoo.
Just saying.
They're there, man.
Gentoo is probably can't look like that thing.
Oh, it's like, this isn't fucking hard to do.
If you want to learn about almost any topic in Linux, going to either the Arch Wiki or the Gentoo handbook is the first step you should do. Because it's well written out and explains a lot of things.
So I apologize for this taking so long to install, but the, oh good, okay.
Take that back.
Not sorry.
Not sorry anymore. But, luckily, I have a local hard mirror, so all the packages, I sync them like every 6 hours or something. So I download really quickly from myself, instead of having to download from the internet. This is the batch prompt. It doesn't look any different than what I had before, which is why I was warning you guys of why I was adding that. I tried to make it so that it would look different. I couldn't figure out a simple way of doing it at 2 in the morning last night. So I am still in that build script, but now I'm in a subshell of that build script. So what I can do is I can go into the work directory, into the root image, and here's all the files that I had that have been installed for me. So what I'm going to do is I'm going to edit the rc.conf, and we'll add host name, we'll enable DHCP, and what else did I have? I think that was it. So yeah, that's all I have. Okay. So now I will exit my shell, and it will continue backline with the build script. Because if you exit with anything other than 0, then this build script doesn't continue for some reason. So, which I learned by, I was putting that in there and I didn't want to make any changes, so I just exit. Actually I was doing Control D, so I wasn't actually executing anything inside of it. So bash was exiting 1, and then it wouldn't continue, and I'm like, what's wrong? So you want to make sure that if you're going to do that, you're going to do something before you exit, or you exit with, exit 0, so that you always exit with the 0 status, so that it does continue. Talking points. Okay, so while we're waiting for that to continue, the idea of how the Arch Linux ISO or Live CD works is that it's built up of layers. There's a bottom layer of read-only file systems. The topmost being ext4 is where it's gonna it creates like an empty disk image and it copies all the files into that. But then what it does is it takes that ext4 disk image and it puts it into a squashfs file system, which is compressed. And because it's compressed, it's read-only. But that allows it so you don't take up as much space on the ISO as you would as if you had to compress all the files, because a lot of those things are they're taxing whatever, so they compress really well. And then it takes a squashfs image and it puts it into an ISO, which is on the ISO 9660 format, which is also read-only. And then above that, it has a top layer of read-write file system. So it has another ext4 disk image, and it stores that disk image on a temp.s, which is it's a location in RAM where you can store files. When you reboot the computer, they go away. And it uses logical volume management to take that read-write ext4 image and overlay that on top of the read-write image, so that you can read through both layers. So you can get the underlying read-only of what the actual system is, and then you have a blank read-write layer where if it writes anything to disk, it goes into that read-write layer, which is stored in memory, and then instead of reading from the read-only layer at the bottom, it reads from the read-only layer or from the read-write layer on the top. Does anyone have any questions about how that works? Okay. Let's check. Okay, so that one finished. We'll copy my KVM script in. Go back to chicken main C. So there we have another live CD that's moving up. So you can see that it's setting the host name to that host name that I set. Now it's starting the network. It's looking for a DHCP server and setting the address.
What does it mean by setting consoles to legacy mode?
I don't know.
I can explain it, but I'm not going to.
So now we have host name. We have our login prompts. We have an IP address already. We can ping the internet. So, but now the really fun thing can start next server. It takes a little while. But it'll eventually work. Oh, come on.
It works about as fast as my computer.
It's working.
So yeah, so now we have a fully working X environment. We will start Firefox. Eventually. And just so you guys know, this KVM VM is running inside of a VMware guest. Running on top of it. Just so you guys know.
Wrong with you.
Oh god.
That was not
like 3 layers of operating system.
Yeah.
No wonder it's slow.
Yeah, you So, Alejandro was asking me if I could make a live feed that has KVM, so I can make more live feeds with KVM. And yes, I can.
But why?
If I
Because
go down here.
Because it
So
sounds
the important thing when
retarded.
you're trying to do KVM is
now you know what it
so
It's
to
getting
do
away.
KVM you need to have these one of these 2 processor extensions. And you can see I actually do have the SVM CPU capability. Sorry? Okay. So because I have that CPU capability, I could theoretically start another KVM guest inside of this live CD if I want to, which I'm not going to do.
The overhead's
Then create
exponential.
another live
It is?
CD.
Yeah.
Start it inside here. And just see how deep you can go before the computer just says fuck you, I'm gonna shut it down now. Yeah.
Further customization that you can do is you can add LibreOffice, you can add carry coverage abilities, you can try and make your own copyist backtrack with pen testing tools, add some messaging client, email client. You can make X start on boot, you can add users, you can customize the loader to automatically start. Further uses is that you can actually take this ISO. Hey guys, I'm almost done. You can take this ISO and you can just copy that straight onto a USB device. Don't copy the file, you actually use like DD with this, something like this command to copy that directly onto the USB device. And that'll let you boot from USB if you need to. Some CDs actually, they have the ability to be persistent so that read-write memory layer is actually going to be stored on another device. You still boot from the CD, but all the changes get stored on another device.
Does the block size need to be?
It just makes it faster.
Yeah.
What is BS? What is BS?
Block size.
Block
Block
size.
size,
Yeah.
yeah.
Okay.
It goes faster than using the default block size of 512 bytes, which is really small.
Oh, damn.
You could make your live CD so that it installs itself to the hard drive, but that's something that I don't really care to do because that's the whole point of making a live CD is to not have to install it. And then some advanced topics are that that bash script, that bash shell that I had to go in and make those changes, you can actually create an overlay where you're going to make your changes in another folder, and then your build script can go and copy those things into the new ISO folder before it does anything. And then the last thing is custom init hooks are things that you can do to customize the boot process so that you can do more advanced things like encryption or some sort of pre-boot customization that you might need to do. And that's it.